Good morning, Prep 1. Welcome to our revision videos. Today, we are going to take a new lesson, which is solving first degree inequality in one unknown. First, let's go and see what is the meaning of inequality. What's an inequality? It's a range of values. So this means that when I'm going to find the solution set, I will find more than one answer that can satisfy my inequality, rather than one set number. If you remember, when we used to solve for equations, I used to have my solution set having only one number, one element inside it. But in the inequality, I will have a range of values. An inequality is an algebraic relation showing that a quantity is greater than or less than another quantity. Have a look here. If I say that x is greater than 45, this means that I am having all the numbers which is greater than 45. X can take any of those numbers. So I have here a range of values. When I say that x is less than 45, I mean that I want all the numbers that are less than 45. So again here, when I used the inequality sign, I had a large range of values, not only one number that satisfy for x. And if I said x is greater than or equal 55, less than or equal 75, this means that I have all the numbers from 55 to 75, all of them are my range values for x. Now, what are the symbols that I use in inequality? I have four symbols. This is less than, greater than, less than or equal, greater than or equal. Any sign of those, when I see, I know that I am dealing with an inequality. Let's have a look here. When I say x is less than 2, this means I want all the integer numbers less than 2. Have a look here on the number line. Here is the 2. I want all integers less than 2. So I will have 1, 0, -1, -2, and so on. What about if I said x is greater than -2? So here I want all integer numbers which are greater than -2. So by looking to the number line, my range of values will be, here is -2. I want all the integer numbers which are greater than -2. So I will have -1, 0, 1, 2, 3, and so on. This sign means less than or equal. So here I am saying that x is less than or equal to 1. When I say less than or equal, this means that 1 is included in my set of values. I want all integer numbers less than or equal to 1. So on the number line, here is the 1. And because it's equal to 1, so I will make the dot solid. This means that 1 is included inside of my solution set. And then I'm going to look for numbers which are less than 1. So here my solution set will be having 1, 0, -1, -2, and so on. Those are the integers which are less than or equals to 1. If I said that x is greater than or equal to -3, this means I need all the integers which are greater than or equal to -3. So on the number line, here is -3. I made the dot solid because I want to say that 3 is included in my range of values. And I also want to take -3 and all the other integers which are greater than -3, which are going to be -2, -1, 0, 1, and so on. Did you notice some of the dots were solid and some were open? As you can see here, when I represented x less than 2, I used an open dot. And when I represented x less than or equal 1, I used a solid dotted. Why? Because here 2 is not included in my range of values, but here 1 is included inside my range of values. So if the symbol is greater than or less than, then the dot is open because I want to say that this number is not included in my set of values. If the symbol is greater than or equal or less than or equal, then the dot is solid because I want to say that this number is included inside of my range of values. Generally, assuming that a, b, and c are 3 integers, then number 1, if a is less than b, then a plus c is less than b plus c. Let's have an example to illustrate this. We all know that 5 is less than 7, right? Now, if I added 3 to the 5, here I will have 8. Is 8 less than 7? Of course not. When is this statement going to be right? If I added here 3 as well. So, now this side is 10, and sure 8 is less than 10. Let's go and see now number 2. If a is less than b, then a minus c is less than b minus c. So here again I have 5 is less than 7. If I subtracted 2 here, then my answer is going to be 3. And if I subtracted 2 here, then my answer is going to be 5. Yes, still 3 is less than 5. Let's go to number 3. If a is less than b, c is a positive number. So I said that c is a positive number. Then ac, which means a times c, is less than b times c. Let's have a look here. If I multiplied 8 by 2 and I multiplied 10 by 2, so 8 times 2 equals 16 and 10 times 2 equals 20. And yes, 16 is less than 20. Let's go now for number 4. If a is less than b, c is a positive number, then a divided by c is less than b divided by c. I have here 8 less than 10. If I made 8 divided by 2 and 10 divided by 2, then I will have the answer of 4 and 5. And yes, 4 is less than 5. Here comes the tricky part in the inequality, and it's about multiplying or dividing by a negative number. If a is less than b, c is a negative number, then ac is greater than bc. Can you see the flip in the inequality sign? Here it was a less than b, and when I multiplied it by a negative number, I got here ac is greater than bc. Let's have a look for an example. If I multiplied here 8 by negative 2 and I multiplied 10 by negative 2, 8 by negative 2 I will have negative 16, and 10 by negative 2 I will have negative 20. The question is negative 16 less than negative 20? Of course not, so that's why I must flip the sign and have negative 16 greater than negative 20. Number 6, if a is less than b and c is a negative number, then we said that when we multiply or divide where negative numbers, we flip the sign. Then a divided by c is greater than b divided by c. If I made here 8 divided by negative 2 and 10 divided by negative 2, so I will have an answer of negative 4 and negative 5. Is negative 4 less than negative 5? Of course not. So I must here flip the sign. So here negative 4 is greater than negative 5. So please pay attention. Again, when I multiply or divide with a positive number, my inequality sign remains as it is. But when I multiply or divide with a negative number, I flip my inequality sign. Let's go now and see more problems of how can we solve an inequality. Solving an inequality in one variable is much like solving an equation in one variable. All what I should do is isolate the variable on one side using the inverse operations. So let's have a look about the inverse operation. We know that the inverse of addition is subtraction, inverse of subtraction, addition, inverse of multiplication, division, and inverse of division, multiplication. Let's go and see this example. Find the solution set of the following inequality in Z, and remember that Z contains all negative whole numbers, 0, and all positive whole numbers. Now I have x minus 3 less than 5. The same we used to do in equations. I'm going to move minus 3 to the other side of the inequality using the inverse operation. Why? Because I want to isolate x alone at one side of the inequality. When I'm going to move minus 3 to the other side, I will have x less than 5 plus 3. So x is less than 8. What about my solution set here? My solution set will be set 7, 6, 5, and so on. Why? Because I am searching for all the numbers which are less than 8 and found inside of Z. Let's have another example. Find the solution set of the following inequalities in Z. X plus 6 greater than or equal to 10. And here my inequality sign is greater than or equal. The first step I want is to isolate x alone at one side of the inequality. So I'm going to move plus 6 to the other side of the inequality using the inverse operation. As a result, I will have x greater than or equal 10 minus 6. Or x is greater than or equal to 4. Again, I want to find the solution set in Z. So I am going to take 4 and all other integers that are greater than 4. So my solution set will be set 4, 5, 6, and so on. Find the solution set of the following in Z and represent it on the number line. So here I am going to solve an inequality and represent this inequality on the number line, or represent the solution set on the number line. If I have x plus 5 greater than or equal to 3, we said that step number 1, we should isolate x alone at one side of the equation. So I am going to move plus 5 to the other side using its inverse operation. As a result, x is greater than or equal to 3 minus 5. X is greater than or equal negative 2. What does this mean? It means that my solution set contains negative 2 and all other integers which are greater than negative 2. So my solution set will be negative 2, negative 1, 0, and so on. How can I represent it on a number line? We said that when I have a number with me, I'm going to make it solid. This is the first number in the solution set, and sure it is with me. So here on the number line, if I read, I will find that I have negative 2, negative 1, 0, 1, and so on. Negative 2 is greater than n minus 4. As you can see here, the variable changed its place. I was used that the variable is on the left hand side, but now I have the variable on the right hand side. But still, I'm going to use the same steps. I want to isolate the variable or n alone in one side of the inequality. So I am going to take negative 4 to the other side with the inverse operation. So 4 minus 2 is greater than n. 2 is greater than n. What does this mean? This means that my solution set is going to contain all the numbers which are less than 2. What are the integers which are less than 2? 1, 0, -1, and so on. When I represent the solution set on the number line, I am going to plot first the 1, which is the first element in my solution set, and then this line is telling me that I have 1 and all the other integers which are less than 1. Find the solution set of the following in Z. Another example. Half times x is greater than 3. We said that the first step, I want to isolate x alone at one side of the inequality. So here I am going to move half to the other side. It is half times x, so I am going to make it divided by half. X is greater than 3 divided by half. X is greater than 6. What will be my solution set here? My solution set here is all the numbers or all the integers which are greater than 6. So my solution set is set 7, 8, 9, and so on. 3x is less than or equal to 9. How can I solve this problem? First of all, I am going to isolate x alone at one side of the inequality. So I am going to move 3 to the other side with the inverse operation. X is less than or equal 9 divided by 3. As a result, I will have x less than or equal to 3. This means that my solution set is going to contain 3 and all the other integers which are less than 3. So my solution set here is all the integers which are less than 3 and 3 as well. Here is the trap and the most important part in this lesson. When we multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol to maintain a true statement. So when I multiply or divide with a negative number, I flip the inequality sign. I change the inequality sign. If it is greater than, I will make it less than. If it is less than, it will be greater than, and so on. Let's have an example to see how can I solve this type of questions. If I have negative 2x less than 8, the first thing I'm going to do is I'm going to move this negative 2 to the other side. But remember, this is negative 2 times x. So when I'm going to move the negative 2, I'm going to make divided by negative 2. When I divide by negative 2, 8 divided by negative 2 is equals negative 4. As a result, x is less than negative 4. Am I talking right? No. We said that when I divide by a negative number, I must flip the sign. So here, x is greater than negative 4. And my solution set will be the numbers which are greater than negative 4, which are negative 3, negative 2, negative 1, and so on. Let's have another example. X divided by negative 4 is greater than or equals to 2. I'm going to move the negative 4 to the other side, but it is divided by negative 4. So I'm going to move it to the other side by multiplying by negative 4. 2 times negative 4, so I will have negative 8. X is greater than or equal negative 8. Is this answer correct? No, because we said that we must flip the sign when I multiply or divide by negative number. So x is less than or equal negative 8. And my solution set here will be all the integers which are less than or equals to negative 8, which is negative 8, negative 9, negative 10, and so on. I would like you to pause your video, try to solve this inequality by yourself, and then go back and see the answer. I have negative 2x less than 6. Again, we said that this means negative 2 times x. So when I move the negative 2 to the other side, I am going to divide by negative 2. 6 over negative 2, or 6 divided by negative 2, I will have an answer of negative 3. X is less than negative 3. Is this answer correct? Exactly, it's not, because I divided by a negative number. I must flip the sign. So x is going to be greater than negative 3. And my solution set will contain all the integers which are greater than negative 3, which are negative 2, negative 1, 0, and so on. Let's have a look at this inequality. 8x minus 3x plus 1 is less than or equal to 26. First of all, I must have the answer of 8x minus 3x. 8x minus 3x is 5x plus 1 less than or equal to 26. Here, exactly as we used to do in the equation, I will have a two-step inequality. When I used to have two-step inequation, I used first to deal with addition or subtraction and then multiplication or division. The same we are going to do here for the inequality. So, plus 1, I'm going to move it to the other side with its inverse, which is negative 1 or minus 1. 5x is less than or equal 26 minus 1. 5x is less than or equal 25. Here is my second operation, which is multiplication, 5 times x. I will move 5 to the other side with division. So, x is less than or equal 25 divided by 5. X is less than or equal 5. So my solution set is going to contain all the integers which are less than or equal to 5. So my solution set is set 5, 4, 3, and so on. I want you please to concentrate here. How can I read this inequality? As you can see, I have two inequality signs. When I read it, I begin with the one in the middle. This is 2x minus 5 greater than or equal negative 7 less than 1. Again, here we have a two-step operation, right? We said that first we are going to move the subtraction or the addition. So negative 5, I'm going to move it, but in which direction? Beside negative 7 or beside the 1? I'm going to move it in both directions. Negative 7 plus 5 less than or equal to x, and in the other side is 1 plus 5. So 2x is greater than or equal negative 2, less than 6. Again, I have here an operation which is 2 times x. I will move the 2 to which side? To both of them. So x is greater than or equal negative 2 divided by 2, 6 divided by 2. X is greater than or equal negative 1 and less than 3. My solution set here will be all the numbers which are included between negative 1 and less than 3. So I will have negative 1 because negative 1 is with me in the solution set. It's less than or equal to negative 1, 0, 1, and 2. When you have two signs of inequality, you will find that your solution set is a finite set. It contains a specific number of values. Those values are determined by x is greater than or equal to what and less than what. By now, we have finished today's lesson. Thank you, Prep 1, and have a nice day.